Hi, my name is Marko Höytyä. I am senior scientist from VTT. In this video we are going to demonstrate how to use history information in selecting the best channels for cognitive radio link. This is our setup. We are going to use USRP, software-defined radio platforms. This unit is the cognitive radio link that we use for streaming video. Then we have a spectrum sensor and then a couple of interfering transmitters. This is the simplistic view of VTT's patent-pending algorithm we are going to use for the channel selection. So first, we are going to use the long-term information to select a set of channels to be further investigated in short term. And the long-term information pre-selection reduces sensing time, and then this short-term information reduces both interference and channel switching rate. So this is how it works. First we are going to look at these 10 channels to find based on some channel quality metrics such as longest availability time, what of those channels are most promising to be used. Then we can see that here are 5 channels that look better than others, so we select those to be further investigated in short term. Then, using more detailed information, we can select best channels for transmission, in this case, these 2. This is the controlling interface of our equipment. You can see here that we are using 5 different ISM channels. Right now we are using channel 3 for the transmission, and as you can see, video is running just fine because there is no interference in that channel. You can also see here marked as current freq, what is the frequency we are now using, and also we can see what is the next channel to jump into if interference happens in the current channel. This red color marks here what channels are interfered, and white color shows what channel is free. Let's add some interference. Now you can clearly see the effect in the transmission. When there is interference in the channel, the video quality is really bad. And the current mode cannot change the frequency. When we change the mode to intelligent one, whenever there is some interference happening in the frequency we are using, the system is able to switch to the next frequency and use that channel for the transmission, and then video is running just fine. We have made measurements using the equipment we have just described and using the proposed method, and compared it to other methods in the work. We have randomly distributed interference among those 5 channels, and none of the channels have been completely free. We have used 4 different methods in performance comparison. So mode 0, where we are not changing channel at all. Then we have mode 1, where we change to the next predefined frequency whenever interference occurs. Then we have mode 2, where we always change to the next frequency. And finally our own method that is able to select the best frequency among available ones. As results show, the more intelligence we have in the channel selection, the more throughput we are able to achieve. And especially we are able to reduce the interference and number of channel changes. Compared to these reference methods, our method is now have reduced the number of channel switches roughly to the half. And this is reason why it is doing so. We have been able to concentrate our transmission to the best channels, that are channels 3 and 5 in this case, and avoid those bad channels, even channel 4 totally, whereas these other methods are also using those bad channels more. Okay, thank you for watching this VTT demonstration on smart resource selection techniques. We have shown the potential benefits of using short-term and long-term information in channel selection, and we have seen that this can clearly improve the performance of cognitive radio link. If you have any questions, please don't hesitate to contact us.